Okay, so last thing, the last part of this, after doing a full write-up, there are several conceptual questions, maybe even, I guess, more mathematical, of different things that they could ask you in this unit. So one of the types of questions they could ask you is, what sample size is needed given that the proportion is this and the margin of error is this? So they're going to give you two pieces of information and they're going to want you to solve for the sample size from that. So before collecting any data, an investigator may wish to determine a sample size needed to achieve a certain margin of error estimation. So for instance, if I'm doing an experiment or doing a study or something and I only want a 2% margin of error, like I want to be really accurate, or 1%, then I can actually calculate what is the optimal or what is the minimum sample size needed in order to attain a certain margin of error. And the margin of error is just the stuff after the plus or minus. So in the formula, for confidence intervals, it's p hat plus or minus z star square root p hat 1 minus p hat over n. That's your confidence interval formula. Well, margin of error is the stuff to the left and to the right of your sample proportion. But you'll notice that in the formula for margin of error, there are p's instead of p hats, and the reason why is you can't obtain a p hat when you don't have a sample at all. Like, we don't have one. So there are two ways that they could ask this question. They could either give you a proportion or you use 0.5. So if P is given, then use that proportion. If P is not given, then use P equals 0.5. Now, I wrote the reason why on the answer key for the confidence interval worksheet too, but you probably were confused about that. But does anyone have an idea of why I would use 0.5 here if they don't give it to me?
No idea. Because it's in the middle.
Because it's
in the middle.
It's automatic.
It's automatic? No, that's not it.
It's the middle.
It just is.
The highest chance of
The largest
So-
value
Small.
for 1 minus p.
It has
Yes.
the largest.
So-
mathematics.
When I do, like if I use 0.5 times 0.5, that gets me 0.25 on the numerator. That is the largest possible combo of P times 1 minus P. So like if I used 0.1 times 0.9, that gets you 0.09. Like that's not as, so the largest possible combination of P times 1 minus P is 0.25. So if I'm trying to choose a minimum sample size and I don't know what my P is, my proportion, like they don't give it to me, then I'm going to be as conservative as possible and use the largest possible combination of 0.5. If you don't want to understand that, that is okay. Just know, yeah.
What?
I'm just playing it safe. So if P is not given, then use P equals 0.5, which is most of the time they don't give it to you.
What?
Oh.
Right, because you don't know what P is because you haven't done the experiment yet.
It's just automatic 0.5.
Mm-hmm. So if I'm going back to the brushing my teeth example 2 times a day and I want to know how many people should I sample, I have no idea what the proportion is of people that brush their teeth at least twice a day. I haven't done any experiments on it yet. And so if I use 0.5 and 0.5, then I can find a margin of error from that based on whatever I choose my margin of error to be. Now, if it's a known statistic that 83% of people brush their teeth twice a day, then you would use that proportion of 0.83. So if they give it to you, use it. If they don't, use 0.5. So, conservative estimate is 0.5. And so here's kind of a proof of why, like I said earlier, the largest possible combination of P times 1 minus P is 0.25.
Is that the way?
So that's why we use 0.5.
Yeah.
Okay, so here's an example of what one of those questions would look like. So in spite of the potential safety hazards, some people would like to have an internet connection in their car. That would be pretty cool.
I have that.
Some cars have it.
I don't pay for it, but I have it.
Some Range Rovers.
That's awesome.
You know the way.
Oh, like when they give you a radio station, you didn't pay.
You know the way?
No, like I can pay $9.99 a month and I'll have Wi-Fi.
That would be really cool.
But like,
My
why
car
do I
is
need
too
that?
old.
You don't need to be on your phone.
That's such
You
a waste
don't.
of money.
It's true.
You're not supposed to be on your phone
So
when you're
it
driving.
says,
It's really
determine the
cool.
sample size required to estimate the proportion of adult Americans who would like an internet connection in their car within 3% or 0.03 with 95% confidence. So the first thing I'm going to do is write my formula. So M equals Z star square root P 1 minus P over N. Okay, so what we want to do is we want to have a margin of error of 3%, 95% confidence. So I'm going to write the formula. M equals Z star square root P 1 minus P over N. Now, the things that I know that my margin of error is 0.03.
What's the 95% confidence?
I'm going to use that for Z star.
Inverse norm.
That's the-
0.975.
You have to assume that
That's
P
the
is
percentile.
0.5.
What would I put in for
Is it 0.9?
0.975.
Or is it 9.7?
0.975 because it's halfway to 100?
Oh, right.
Don't get tricked.
And you get
She said not to do that.
You get.
1.96 or something like that.
1.9.
And I don't know. Stop talking. And I don't know what P is. It's not given, so I'm going to use P equals 0.5. So I'm going to plug in everything that I know. So 0.03 equals 1.96 square root 0.5 times 0.5. You can honestly skip a step and just put in 0.25 because it's always going to be 0.25 over N. Now, when you're doing this in your calculator, you must keep all decimals because if you round anywhere in this, you're going to get the wrong answer. So, must keep all decimals. Now, you do it all in your calculator. So, get your calculator out. I'm going to show you the steps. Okay, so first step is I'm going to get the full decimal of this really quickly. So in my calculator, I'm going to type in,
Same norm.
inverse norm. So first thing I'm going to do is inverse norm. So I'm going to go to second bars, inverse norm,
How you make your calculator?
and 0.975, 0 and 1. Keep this decimal, okay? So even though it rounds to 1.96, I want to keep that because it's going to make a difference whenever I am finding the sample size. So based on my formula, which is the 0.03 equals 1.96 square root 0.25 over N. If I were solving this algebraically, the first step I would want to do is divide by the 1.96 on each side. 1.96. So, in my calculator, I'm going to type out 0.03. So, 0.03 will work. Come on. 0.03 divided by, and then I'm going to just select this and hit enter. Enter. Now when you're showing your steps, you can round, but when you're actually doing it on the calculator, you want to keep all of the decimals. Yes, so 0.0153 equals the square root of 0.25 over N. What would my next step be if I'm solving for N? Square it. So I'm going to square each side. So I'm going to select.
No. So what do you do because does this not change it to plus or minus? Is that only when it's square root?
Yeah, you don't need a plus or minus. So I'm going to hit enter, and I'm going to square it. And you're going to get a really tiny number. So 0.000234 equals 0.25 over N. And then if I'm solving this algebraically, multiply by N, and then divide by 0.00234. So n equals 0.25 divided by 0.000234. So I'm going to type in 0.25 first and then select my answer. And you get 1067.07. So you always round up. Because if it's asking you for a minimum sample size, 1067 will not be big enough. You have to do 1068. So always round up the sample size to the next whole number. Even if it were like 0.0001, you would still round up. So always round up. Okay, a few more things I want you to write, maybe like at the bottom of the page or maybe another blank page or something. Just a few more kind of concepts that are not on the PowerPoint that you could potentially see asked to you. So they could give you, so here's a few like multiple choice things they may give you. So let's say that they give you a confidence interval and it says the confidence interval is from 0.3 to 0.5. I'm going to make this simple. And they said, what is the point estimate? What is the margin of error? So if it said, what is the point estimate? How would I figure that out? They just give me this, right? So if my formula is p hat plus or minus z star p hat 1 minus p hat over n, you don't have to write all this out, but if you're thinking about a confidence interval on a number line, you've got 0.3 and you've got 0.5. Your point estimate is always in the middle, which is your p hat, so 0.4. And my margin of error is always the distance from your point estimate to the outside. So to find your margin of error, you can take the range and divide it by 2. And then to find the point estimate, it's just your average or your center. So my margin of error in this case would be what? 0.1. So I go plus 0.1 minus 0.1.
Miss Thornhill, could we just find the interval to begin with, like the question we just did in the back to find margin of error? Couldn't we just find the interval to begin and then do range over 2? Or do we have to do the formula?
Yeah, you can do it from the beginning. Yeah. Another thing that they could ask you would be, what is the standard error given 90% confidence? So if I know that my margin of error, which is this whole thing, is 0.1, so 0.1 equals z star square root p hat 1 minus p hat over n. And it also gives me 90% confidence. Standard error is just the stuff under the square root. So what could I do to figure out just the stuff under the square root?
How do you know the n?
You don't.
Oh no.
You don't. You just want to know this, but can I figure this out with the 90% confidence?
Yes.
I could. So I would do inverse norm, 0.95, 0, and 1. And you get 1.645.
Oh, so then you just divide.
And then you divide 0.1 divided by 1.645. So my standard error, SE, my standard error is 0.0608. So those are like 3 different things that they could ask you based on if you're just given a confidence interval, but you're given no other information. Okay. The last thing that they could ask you is, let's say that you have done all of your, you've done your full write-up, and then it comes to the last problem. So 4B on the confidence interval worksheet number 2, it gives it, you calculate a confidence interval, And then it asks you, can the proportion be less than the national average of 0.25? So essentially what the question is asking is, can the population proportion, can P equal 0.25?
Like, is it within the range?
And so what you're doing is you're looking at this right here, and you're comparing it to the confidence interval. So if P is contained, and this is saying less than 0.25, mostly or most of the time questions would say, can it be the national average? So we're going to change that to say, could 0.25 be the national average? Instead of saying less. That's really ambiguous. So could the national average be 0.25?
Yes.
So the way that you would write it, or the way that you would phrase it, is you would say, since 0.25 is contained in the, was it a 95% confidence interval, the national average, blah, 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 could be 25%. Then if, let's say 25% were not contained, you would say is not. Then the average could not be 25%. So essentially all you're doing is looking at your interval. If the P is contained in the interval, then yes, it could be your national average, but if it's not, then it could not. So your your population proportion will always be contained in your confidence interval if it asks you a follow-up question about that. So those are just some extra tidbits of things that they may ask you.